morning, everyone, and welcome back to Foundations of Computing. So once again, we have the model of our computer that we're going to be playing with today. And if you remember from last time, this was only going to be useful when it actually performed a function on some input to generate our desired output. So today is going to be learning about some basic Python skills to actually do this in useful ways. So in the middle, we could label what we have, what's performing the operations for our program, as a function. This is a term that computer scientists use to refer to a small set of instructions that are going to perform a single task. So if we go over to my other machine for a minute, let's see if this works today. Beautiful. We have our very first example of a function that we already used last week, our print function. And our print function was going to display something on the screen, and in this case it was displaying for us hello world. So just as a reminder, let's run that. So I'm first going to change to my Foundations of Computing directory, and then run the Python command for hello.py. Now, many of you are using Grok to do your exercises, so you won't have to do this process, but it's important for you to see it now because this is the way that once you graduate beyond Grok, you'll actually have to run programs using the command line, using the terminal, this area here, which allows you to instruct the computer directly to what you want it to do. So there's our first function, hello world, and it takes in some input, and as output, instead of giving something back to the program, it gives something back to the user directly. It displays something to the screen. So we could use some other language to describe what's going on here. So we're going to say that the inputs to a function are the arguments, and what it gives back to the program, not back to the user, but back to the program itself, is going to be the return value, because that's what's being returned to the user. But the print function doesn't actually seem to be returning anything. It's displaying something, but it's not giving anything back to the, there you go, you need that. But it's not actually giving anything back to the program itself to perform further processing. But remember from last week, when we used Scratch, we didn't just want to say hello world. We wanted to actually greet the person who was running the program. So we'll need to modify our program a little bit to do that. So let's go ahead and use our second function. And this is going to be the input function. So just like the ask block in Scratch or in Blockly, we're going to be able to do that here. Okay, so input, what is your name? Let's give this a run. What is your name? Okay, that's not looking so good. So remind me your name again? Arthur. Arthur, that was it. So Arthur, why is this not doing what I want?
Because you haven't a equals to input.
At a more fundamental level, what have I done wrong? Not with the program. Don't look at the code itself. What's the problem? No looking at the code. Eyes on me.
Not helpful in input function here because say you got an argument here, but the return value is not helpful.
So that's a very technical way of saying something much simpler, which is that I've asked the user for input, but I haven't actually done anything with the output yet. So I'm going to need a little more Python experience in order to be able to turn this into something useful. Just like in Blockly and in Scratch, we would compose the blocks to take the output from the ask function to feed it into the say function. We're going to need to do something similar in Python. But to do so, we'll need a new tool. So one way we could do this is using composition. So if you imagine a whole program is a composition of a lot of different functions, and we can chain their inputs together, just like you might do in mathematics, where you would compute, say, a function h of x, and then you could compute g of h of x, and you could compute f of g of h of x, and thereby you take the output from the h of x function, and you feed that into the g function, and you take the output of all of that, and you feed that into the f function. Now, we could also do this with multiple arguments. If, say, the function h doesn't take just x, but also takes a y and z, and then we can feed all of that output into our higher and higher level functions. Seems pretty straightforward, but unfortunately, Python isn't mathematics. So instead, what we're going to do conceptually is we're going to find a way to let the computer store the result of a function in these boxes that we are going to call variables. And then we can use this variable, this where we've stored the answer, and we can feed that into another function. So now let's take the output of h of x, y, z, and we'll use that output as the input to g, now that we've stored it in this box. And then we can actually store that back in the same box again. So let's throw out what was in the box before and replace it with the output of g of our variable. And then we can do the same one more time. We can now run f on the variable that's updated again to finally get our answer, which is the composition of f of g of h of x, y, z. So how do we do this in Python? Well, let's take a go. So fortunately for us, the syntax in most programming languages to create a variable is not too difficult. In fact, the main thing we need for it is a name for the variable, some way to refer to this box in future, because otherwise the computer's not going to know which of the many boxes in its memory we are referring to. So what would make sense, just very quickly, Arthur, to store the output of what is your name? What should we call the box that stores someone's name? Name seems like a pretty good choice. Okay, so I'm going to type name equals and then input. Now you'll notice that this is not quite the same as the mathematics you're familiar with, because this equals sign is not actually checking that the two sides are the same. What this equal sign is doing is it's saying run the computation of everything on the right side. Run that program. And when you're done with that, take the program, take the result of that, and feed it into the box we call name. So it is just like our literal notation here, where we take that and place it in the box. So now I'm going to run our program again. Arthur, do you want to pass it to Drea? And I'm going to run my program again. What is my name? Drea? It's still not working. Well, what am I doing wrong?
Didn't use the result of the well.
Yeah, so I haven't actually used what I've created yet. So let's give this a try. Do you notice something else funny that looks a bit odd about the output that's happening here? Yeah, I'm missing a space. So let's fix that up. Let's run that again. Hello world. Okay, that's looking prettier, but still not working. So maybe what I can do is I can compose the print function twice. So I could do, not compose, maybe I could use the print function twice. And I could do name. Okay, let's try this. What am I doing wrong? Drea, what do you think? What he said, what did he say?
Quotation mark.
The quotation marks. So what the quotation marks are doing is they are turning what could be a variable name or an instruction to the computer into what we call a literal. Again, as we said in the last lecture, this means the computer takes whatever's inside literally. It doesn't run it as a program. It doesn't go find the box, doesn't go find that variable. Instead, it treats it as the set of letters N-A-M-E, which is not what we're looking for. What we actually want it to do is we want it to go to the box called name and take that out and then use that as the input for the print function. So it was, to start with an A? Yeah. Is it Andrew? No. Alan, okay. So Alan suggested we try this. Let's run it again. And I'm going to this time run the clear command before I actually run the program to just give myself a little more space on my terminal. So I am now going to run Python hello.py. What is my name? Drea. Hello world, Drea. Okay, that still doesn't look quite what I want. What's ugly about the output now? I really wanted to say hello, Drea. Okay, I'll give you the microphone when it's your turn. But Drea, what's the problem? It's not one sentence. Okay, so what we really wanted to do is write hello Drea. What change should I make to make that happen?
This word.
Okay, so I'm going to delete.
Conditional.
Let's try this. What is your name, Drea? Okay, that doesn't work. That puts it on a different line. I could try this. Let's see what happens then. What? Invalid syntax. Perhaps you forgot a comma. We'll return to this soon, but we still haven't quite solved our problem. We're going to need to learn a little more about our print function before we're actually able to solve this problem effectively. But for now, let's go back to our discussion of variables, just quickly so you understand a little more of what's actually happening inside the computer's memory. So you can think of the computer's memory as a vast expanse of blocks. And in each block, we could put some words. So for example, if I create a variable name, I could use one block. Each block could store a letter for me. And so I could have the name David spelt out in blocks. And then what name is it's a way to tell the computer which set of blocks I'm referring to. But of course, if we only have one variable, we're not going to get very far. We probably want to do something a little more sophisticated. So how about I create a second variable? So I'm going to go back into my program for a second. And we'll just go with the version we had before that wasn't quite right. And we're going to create a new variable, age. And let's make this 30. Now you'll notice something different about this variable compared to the other variable. Drea, do you want to pass it to Maka? What's different about this variable?
With age, we're not asking the user to input anything. It's defined as 30. Change.
So we're not asking the user to enter anything, so it seems like it's more static in a way. There's also something else different about it. So what if I were to do... What's different about these two variables?
Different data type. So age is whilst last name.
So Maka's telling us there's something fundamentally different here. Because one of them, you put in quotation marks and it's a set of letters. And the other one is numbers, but you didn't actually put those numbers in quotation marks. So this is referring to what we call in programming types, or data types as the long form. And what it's saying is essentially there are different ways that a computer can manipulate and store information. The way we're going to want to manipulate strings, this type of data that contains lots of letters and characters and symbols, is going to be different from the way that we'll want to manipulate numbers. And these are going to have different behaviors and different functions that work on them. For example, you might want to round a number up, but it's not going to make much sense to like round a string up. What's rounding someone's name up? That doesn't make sense. So depending on the data type you use, you're going to have different functionality associated with it. And as we're going to explore a whole bunch of different functionality built into Python that allows us to explore these different data types. So let's go back to our picture. And so I've created a new variable, age. And now we've still got our old variable in memory there. It hasn't been deleted. It's still sitting there in some of the boxes. But all we've done is actually created another set of boxes for us to store the number. Now, this gives us some interesting questions about the relationship between boxes and storage and how we'd actually make them more useful for us and manipulate them. So let's do a few little practical demos in Python to see some of their limitations and some of their functionality. So let's start afresh. I'm going to create a new file, and we're going to call this games.py. And so now, when I run my command Python, instead of typing hello.py, which was my old file, I'm going to type games.py. And I'll actually make sure that is in the right folder. There we go. Okay, nothing. Maka, why is it printing nothing? Yeah, there's nothing in my file yet. Okay, so we actually need to do something. Maka, do you want to pass it back a row? Okay, you're still safe for the minute. I'm just making sure we've got you lined up for when we have a question. Okay, so let's do some very simple things. So for example, we can manipulate literals literally just like a calculator using Python. So if I were to do a equals 4 minus 1 and run this, what was your name? Angel? Why is it still not doing anything? I mean, I put some code in it now. What have I forgotten? Yeah, I've forgotten to print. So I've told it to do something, but again, unless you tell the computer that you actually want to display something to the user, it's not going to do that for you automatically. So let's add print A. Okay, and now we see our answer 3 down there at the bottom. And I'm going to clear the terminal again just to give us some more breathing room one more time. Okay, so now what we can do is something like this. And I'm going to print A, B, and print C. Now, Angel, what do you think is going to happen when I press enter here? And no cheating, Alan, I know you know the answer. Okay, so what are we going to get when we print A? Who said that? Who else is cheating? Okay, it's Angel's turn this time. We'll get to you later, promise. What was your name? Who just said? Who just said 3? Yeah, what was your name? Tim. Okay, great. We'll get to you later. Angel? So we print A, and what do we see? 3? Okay. What about when we print B? What do you think we'll get? We'll get 3 again, and what happens when we run the code on line number 6? You can see the line numbers there. What will we get? Nothing? Why do you think we'll get nothing? Say it loud. Be confident. I can't hear you very well. Yeah, so Python, it turns out, is going to be case sensitive when it comes to variable names. So if I run this, Angel was very, very nearly there. She semantically got right what the program should do for lines 4 and 5, but we have a syntax error because we haven't created a variable lowercase c anywhere in our program. So when we run our program, we're actually going to get an error. Name error, name C is not defined, and in fact, this version of Python is going to very helpfully ask us, did you mean C, capital C? Okay, so now we run this, and Angel, say it very out loud for us. What's going to happen now on line 6? What are we going to see? We're going to see 3, and indeed we do. And this is one interesting thing, again, about programming syntax, is we're not checking that B and A are the same thing. We are not putting B inside A. What this syntax does is it takes whatever is on the right-hand side and puts it in the variable that we have named in the left-hand side. Okay, so now let's try one more demo. Thank you very much. Angel, do you want to pass it to Tim? Because I know he was... No? Are you sure?
I misunderstood. I thought that it was a general question.
That's okay. Okay, so who's got it now? What's your name? Aditi. That is a lovely name. Okay, so we're going to try a new demo now. What do we think this one is going to do? So that was a good point. I hadn't put any print statements. Now what am I going to see? 555, let's give it a run. 555 indeed. So what's actually happening is the Python interpreter, the program that runs our Python programs, is actually breaking this line up into a sequence of moves. So first it's doing setting z equal to 5, and then it's setting y equal to z, and then to the result of what's in these parentheses, and then it's setting x equal to all of that. So indeed, we do get 555, despite the fact that this syntactically looks a little funny. Okay, now let's say I'm having an interesting day, And what's a rhyme that had, give me a second. I want to think of something. We'll try this. So this time I want to name my variable for I have a trick. It's just a set of numbers. Aditi, what's going to happen? Oh, you've been reading ahead. I don't have any tricks. Okay, so Aditi is right. I'm going to get a syntax error when I run this. Why? It looks like perfectly valid code. Everything I've told you so far should lead you to believe that this would actually work. But every programming language has a number of words that are reserved. They're special words that you can't use as variables because they're so important to the design of the language itself. And as we will see in, I think, next week, the word for is actually a very important word in Python's language because it allows us to repeat things without having to repeat the actual code we use. So we are not allowed to use certain words as variable names, and if you accidentally use one of these as a variable name, you will indeed get a syntax error just like this. So now, if I change this to for, all caps, will it work? It works, but is this a good idea? Why is it a bad idea?
The only difference that you have between both of the error and the right statement is the capitalization, which is not in this usually.
So who are we writing the code for when we write code? Who's your audience? Like when you write a book, who's the audience of the book? People, right? When we write code, who's the audience for our code? People as well. So your code is not just for you. Your code in life is going to be read and written by other people. And who's the most important person in the world, other than me? Yourself. So if you write code that is hard to decipher for yourself, when you come back to your code, or when you try and make it work, or when you try and debug it, you are going to have difficulty. And so this is where we talk about code style. It's not just about the functionality of the code, but is it easy to read? Does it make sense? Is it designed in a way such that when you need to modify it, you can modify it easily and effectively? And so in this case, using the word uppercase for as your variable, probably not the best idea because it's just a little too close to comfort for Python's built-in word for. And in fact, most languages are going to have a word for. Not every language, but many languages do. And so this is probably a variable name that one shouldn't use in any language unless you have a really good excuse. So some other words that you might not want to call your variables: for, if, else, while. There are a whole bunch of these. Anytime that we teach you a special word that's used to do things in Python, consider not naming your variables that name. Okay, so we have one more interesting Python demo. Now, this is, again, you're gonna give me strange looks for this, but what is this code going to do? Okay, we'll see what happens. Before, it gave me invalid syntax when I tried to do this. Type error, int object is not callable. Now that reads pretty differently. It's not the same as when we use one of Python's special built-in words. So let's try this a little differently this time, and I am going to put a comment on line 2. And a comment is, this is a note to a human. This is not something I want the program to actually run. And in Python, the way we indicate a comment is by starting a line with the pound symbol, or what many of you might call a hashtag, even though that's not the proper name. So the second we do this, if we're using a good code editor, that line is going to turn green or fade out or turn a different color. And this means when the program runs, it's not actually going to run that line. So let's see what happens now. Can I set print equals to 14? Whoa, that actually worked. So it turns out that print isn't one of these special words in Python that's so fundamental to the language. But print is an example of a, starts with an F, we've talked about it a bunch, function, right? And Python allows you to use a function's name as a variable name, and it just overwrites it if you do that. So if I had a function called sum, I could still set a variable to be called sum, but what happens is I've now lost track of that old sum function. I don't have a way to access it anymore because I can't use its name. I'm already using its name for something else. And that's what's actually happening here. Let's try this again. With print 14, that'll work fine. But now if I do print, this isn't working because print is no longer a function in this program. After I finished running line 1, print is now, fill it in for me. It's a variable, and what is the variable? What's in the variable? What's inside the print variable? Line 1? 14. And so the error that I'm getting is an int, which is Python's integer type to hold numbers, is not callable. And callable is when we want to run a function, the other terminology we use to talk about running a function is to call a function. And so if something is not callable, that just is saying it's not a function. So if we now look at our error again, int object is not callable. So it's saying you can't run an integer. An integer is not a function, so we can't call it. Integer is not callable. And as you gain more experience, these rather opaque and difficult to understand error messages will suddenly start to make sense as you learn more and more about different language features and more about programming. Now, of course, another thing you can do is to paste this kind of error into Google, and actually many programmers in the real world do this on an everyday basis. I frequently find myself pasting in error messages I do not understand into Google to understand a little more about the context. Perhaps there are some words I don't know. So if you are doing this, it is a sign that you are actively learning, not a sign that you are doing something wrong. Thank you very much, Aditi. So now I need 2 volunteers. So I will take 2 volunteers. Already had you, Tom, was it? Last class. Okay, you're new. So come down to the front. Yep. And I need 1 other volunteer. I'm volunteering you in the collared shirt. Yeah, right there. Yes. Okay, so now we want to have some more fun with variables. And so I've actually brought some, you know, in those cooking videos, here are some variables I prepared earlier myself. So there's your other variable. And where is the, oh, I've got another microphone here. That's very convenient. Okay, so let's wait for that to go on. There we go, it's on. Great. So what were your names?
My name is Angbo.
Amber?
Angbo.
Angbo. Awesome. And?
Chi.
Chi. Great. So you two are going to do some swapping for me. So let's call this jar, jar A, and this jar, jar B. And these are going to be our variables. And what I want to do is I want to swap the contents of A and B. So for the moment, you're going to go over to the side. And I want you to put yellow in there and green in there. You've just swapped hands. They're still the same jar, right? That's still jar A. I know a trick when I see it. Okay, put them back. Okay, I want you to put the contents of jar B into jar A and the contents of jar A into jar B. I'll tell you what, I will help you.
Yeah.
There you go. Go for it. Is that going to work?
It's not gonna work. It's gonna overflow.
And even if we were to do it that way, that wouldn't swap the colors, would it?
Yeah. Yes.
Now so what's going wrong here?
what's going wrong is it's gonna overflow and it's gonna mix together.
And it's going to mix together, and that's not how we swap, is it? So what are you missing? What do you need to do this properly?
I need an additional bottle for this.
Do we have one?
I think we do.
We think we do? We've got a friend? Okay, we need a round of applause for our friend Engbo. And he is going to bring us, and what are we calling this variable? If that's A and that's B?
C.
C seems pretty good. Okay, so I am going to write up on the board A, B, and C and create my 3 variables. So A is yellow, and B is green, and C is empty. Okay, so we can start it with empty, or we can create it when we need it. But let's start it with empty just for clarity's sake. Now I'm going to print A, print B, and print C. And I'm going to run games.py again. But now I'm going to rename this to something a little more illustrative. We're going to call it swap, because that's our goal here. There we go, swap. Okay, so Chi, you're going to very slowly give us some instructions about what we do both in our program and in our demo. So we want to swap. Drum roll everyone. Drum roll, not claps, drum roll. There we go. Okay, Chi, what's the first step?
I will call this variable A.
Yep, that is A. A is yellow.
This is B.
Yep,
First thing I will do is to fill up the empty bottle.
which is?
C.
Okay, so C, what are we putting inside C?
Put it inside A.
So C gets whatever was inside A before. So that's what we're doing. Okay, go for it, go for it. You can do it. And look at how perfect that pour is. Okay. So C equals A. Now, question, in the program world, is A now empty? No. A is still going to have, if we were to print A here, oh, that doesn't work. I need to run swap.py. We go. So I can see it's still got yellow in it, but it's okay for our purposes. So what's our next step?
The next step is I will fill B into C.
Okay, B, go, wait, is that C?
Fill B into A.
Okay, B into A. So, wait, before you do that, what am I going to write on my code?
B equals A.
B equals A? So we've just saved whatever was in A into jar C, which has left us with an empty A jar.
B equals A.
If B equals A is putting whatever is inside A into B. Well, that didn't help very much.
So A equals B.
A equals B, that sounds like a better idea. A equals B. There we go. So now we can print B, and I'm going to take all of these away. So now we should have yellow in A at this point. Oh, let me print A again. I'm going to cancel that. So now I should, before I did that, I would have had yellow in A, and now I've got green in A, right? Green in A, okay, and what's our last step? What's the empty one? Empty one is B, and what did we want to do? That sounds like a good plan. So what jar is that one?
C.
C and B. So what do we write in our code?
C was.
So C equals B means take whatever is in B and put it into C. So take whatever is in B and put it into C.
B equals C.
B equals C, that seems better. Okay, so B equals C. And now at the end of all of this, I'm going to print A and print B and see what our results are. And now we have green is in A and yellow is in B. And that is the opposite of what we started with. So we have successfully performed a swap, but to do so, we needed our friend and our extra jar. It was Angbo, right? Yeah. And so can we have a huge round of applause for Chi and Angbo for doing our swap? Thank you very much. And thank you, Alishka, for filling one of the jars and then emptying it out again. And to, who was the other person who helped out at the very beginning? It was not Bennett, Bassett. Second time I've done that. Okay. I've done that. So this gives us the ability to start to do more sophisticated things now that we know how to use our variables a little better. So the next task is, you'll remember at the end of last week, I had a question for you, like, could we generate Fibonacci numbers using just two variables? So let's see how we might generate the Fibonacci numbers. Remember, Fibonacci numbers are, let's create a new file. I'll call this fib.py. And Fibonacci numbers are the new Fibonacci number is the sum of the prior two Fibonacci numbers, where the first two in the sequence are 1 and 1. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. Thank God you guys can do grade school maths. Okay, so let's try this out. Let's set A equals 1 and B equals 1. So how would I generate the next Fibonacci number? And let's pass this off to someone new. Let's go for a bit of a run. Okay, there you go. Yeah, shock! You actually have to be awake. What's your name? Gary. Gary. Let's see, is the green light on? We're green, okay. So hold the microphone up close. Okay, Gary's going to help me out. Okay, how do I generate the next Fibonacci number? The third Fibonacci number is the sum of the first and the second Fibonacci numbers, which I've got up on the board. So what line of code would I write to generate the third one? Who said that? Who's our cheater? It was Yingdo. Gary?
Plus B.
A plus B, okay. And I guess I could print that. And let's run Python fib.py. Oh, it's in the wrong directory again. There we go. Okay, so that generates 2. But now I want to generate the next Fibonacci number. So how would I do that? So I could have another variable, and I could do C equals A plus B, right? And then what would my next line be? So A plus C, A was the first one. So if we call this first, second, and third instead, to generate the fourth, the equation to generate the Fibonacci sequence would be third plus second. Oh, and then, right? And then we could print fourth. So if I was going to do fifth, what would the equation for the fifth be? Same pattern. Be third plus fourth, right? Third plus fourth. But this is going to get pretty tiring pretty fast, because I'm going to have to write a new line of code for every Fibonacci number I want to write, and I'm additionally using up new boxes of storage for every Fibonacci number. So probably not the best approach. So let's see if we can do it just with first and second. So I can do something like this. And now this is just like what we were doing before, except now we're overwriting one of our variables with the result of whatever is on the right half. So we run the right half, so it computes first plus second, and then puts the result into first plus second. And then we could run this again. We could do first equals first plus second, or even better, we could do second equals first plus second. Now let's see what we get. And that seems to be working. But we still haven't really solved our problem, have we? We still have a problem. Do you want to pass the microphone back one? See someone behind you? What's your name? Juhi? You're going to have to say it much louder. Jyoti. Awesome. So what's our problem still? What's annoying about the code?
Same variable, and it might get confused, we might get confused.
Well, firstly, it's a bit confusing. This is kind of hard to read. And the second thing is, let's say I want to generate like the 6th or 7th Fibonacci number. I'm still doing this thing where I'm going to have to repeat over and over and over the lines of code. So we haven't really solved our problem. But to solve this, we're going to need to turn to a technique that we haven't yet discussed in class. So we'll come back to that a little later. But for the last couple of minutes before I turn over to Kat, who is now here with us, I want to talk a little bit about different things that we can do with strings. So we're going to call this string formatting. And formatting is the technique by which we take a piece of data and we get it to display or get it to be stored in a way that's useful to us. So what's something, if I give you a whole list of people's names written in lowercase, what's something you might want to do? If they're all in lowercase, what's something reasonable that one would want to do with a bunch of lowercase names? No, like on a piece of paper, right? If I give you someone's a lowercase name of a person and you want to write a letter to them, how are you going to format the name? Would capitalize it, right? So we're going to want to find ways in Python to manipulate strings and manipulate different variables to actually display them in a way that's very useful to us. So let's try a few of these different examples going back to our hello. So, oh, who's there? Okay, so let's go back to our hello example, only this time I am going to print my last name in lowercase. And I am going to run python hello.py. Okay, that still doesn't look right. And worse, let's say the user accidentally enters a whole bunch of spaces. So I'm going to enter a whole bunch of spaces. Oh, they're not going to display anyway because I currently have them on separate lines, but we'll come back to that in a second. So I'm now going to show you another technique for string formatting that you can use. So let's say I do print name plus last name. Now, this seems a little weird. How can you like add names together? But we'll see what happens. Okay. That worked, but there's no space there. I guess Python actually understands that string types, when you do addition, what the user probably means to do is actually what we'd call concatenation, which is joining the two strings together as if you just are going to append the letters from the first string to the second. So we could do that, and in fact we could even add a space of our own, doing one more concatenation with this. Okay, but we still haven't solved the problem with the capital. Okay, so this is where Python's built-in functions come in handy. Now, Python is incredibly useful because it has so many built-in functions. Now, admittedly, this is also a challenge for us in Python because you might not know what all the functions are available ahead of time. And so for that, we're going to do something called reading the docs, or reading the manual, or RTFM if you've been on the internet too long. And fortunately for us, Python does have all their documents available publicly online, very easy for us to find, And if we wanted to look up, say, all the different base functions that Python has, we could find them at this address, and feel free to go and browse them. So I'm just going to give you a couple of examples of different functions that we might want to use before we turn over to Kat. So one I might want to do is I will apply a function called the strip function, which is going to remove all the extra spaces that the user has put on after that they've entered. So let's try this. If I do sha-none, and then I put in lots and lots and lots of spaces, press enter, spaces don't appear, they're magically gone. And now if I do .title, that's going to put it into title case. So let's see what happens now. That's starting to look a little better. However, I've still got this funny thing where it's on a different line. That's a little frustrating. Well, I guess I could go to the Python manual and look up the print function, and there I'd see this mysterious syntax. And we're not going to worry about too much of it for the moment. However, let's try this end parameter. And if we read the docs, they'll probably give us some examples as well. So this is telling us that print is going to start with a list of things you want to print, some objects, and let's not worry about the star for the moment. Then it's going to have two optional arguments, sep and end, and let's play around with the end one for just a second. So let's do print all the things we want to print, and then let's set end. Let's do this above. Print all the things we want to print, and then let's set end to another string, hello there, and see what happens. Okay, that is definitely not what we wanted, but at least the new line is gone. So why don't we try just giving it a string that's totally empty? We'll give it 2 quotation marks, but put nothing inside. So give that a try. Almost there, but not quite. What might be a better thing to put in there? Anyone have an idea? A space? Okay, let's try that. And I'll even do you one better. I'll put it in a comma and a space. So, and there we have our hello world. Now, one last thing before I turn over to Kat. You'll notice that I've used this interesting syntax to actually run the functions. So what this syntax is saying is, I want to use the strip function, but the strip function actually belongs to name. Name is a string, and every string comes built in with a bunch of functions that work on that particular string. Integers will not have this as well, but some Python types will and some Python types won't. And to figure this out, that's where we're either going to turn to the manual or we will help you out in the early parts of semester. So this is dot syntax, and we're actually going to call this accessing the method of a variable or accessing a method of the particular object that we're dealing with. So name and last name, both as strings, have a bunch of built-in methods, a bunch of built-in functions, and this is going to be the way that we're running them. And you'll notice that they're just functions just like any other function. We call them by putting parentheses, and they might also take arguments. How to figure out what arguments they take? Well, that's for the manual. And can we have a round of applause for Kat, who is about to join us? And we will take a 3 or 4 minute break just for Kat to get set up.
Okay. So let's continue on strings, and we will also start the new topic on conditionals and the Boolean data type. But before we start, let's do some recap what we learned so far. And when I was thinking about this, I recalled this funny episode from Alice's Adventures in Wonderland, where she talks to the Mock Turtle about some regular course that the Mock Turtle took, and it asks, what was that? And the Mock Turtle replies, reeling and writing, and then the different branches of arithmetic, ambition, destruction, uglification, and derision. So I very much hope that you learned much more than this Mock Turtle, and in order to get more feedback, you of course need to talk to your peers, you need to talk to your tutors, to the lecturers, and so you make sure you do not arrive to this in the same state as mock turtle to the exam. So let's recall what we know so far. So you all learned some basic math, how to use Python as a glorified calculator, right? We know how to perform addition, subtraction, etc. So let me switch to Grok. You all know that in Grok there is an option to use the terminal. You just click the terminal button, right? And let's recall some basic data types that you already know. Which data type do we use for numbers, integer numbers? Yeah, it's called int. And we can always ask, what type are you, for instance, 34, by typing type. And it says this is an instance of the class integer, int. So in Python, everything is actually at the end object. An object is an instance of a class. We'll discuss it in more detail in the advanced lecture on object-oriented programming. But for you, it's important that whatever number you put, as soon as it's integer number, if it's small, if it's big, if it's negative, positive, it's still integer. Unlike in other programming languages like C, where you have to think in advance how big your objects will be, how big your values will be. So if it's negative 34 something, for instance 34 million, you still will have the integer. Yeah. So even if it's 0, if it's negative, positive, if it's a small number, large number, it's still just integer. And the memory is allocated dynamically. So what data type do we use for the decimal point numbers? Float, exactly. So if I type, what type are you? 0.5, I always get float, right? It can also be 0.0005. It's still float. If it's negative, it's also float. Whenever you see the decimal point, it's always float. Now, who can tell me what will be the result of this division operation? So, for instance, 7 by 7. Yes? Float. Yeah? If we apply the usual division, it's always float. So if we just perform the division without asking type, it's still the number with the decimal point, 1.0, not 1. There is a special division in Python that is called floor division that guarantees for us to get integer. So then we have integer. So, and finally, we just started with strings. How do we specify that our value is a string? What do we need to put? For instance, if I want to say that actually this number 0.0005 is a string. Yes? Yeah, we can put this either double quotes or single quotes. Then it's automatically processed as a string. We can put single quotes. We can even put triple quotes. But be careful, if you start with single quote and then you finish with double quote, you'll get an error, of course. You need to be consistent with which quotes you use. And we also discussed just recently, Shannon mentioned, what happens when you use this plus sign on strings. What happens? How this operation is called. Yes? Yeah, that's right. It's concatenation. We just glue strings together. And have you discussed this multiplication thing? So there is a special interpretation of this multiplication sign for strings. If I want to say hi 3 times, I can just put this 3 times hi. So it means repeat the string hi 3 times. Or I can also put 300 times. Hi, 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 hi. Very straightforward. And you can see that this particular operator multiplication is overloaded. So it's sort of like it has one particular interpretation, semantics, when it's applied on numbers, it's multiplication. If it's applied on string and number, it means you repeat this string that number of times. This is called operator overloading. So the function of this operator is different depending on the data type. But of course, you cannot perform something like that. It will not make sense. If you multiply one string by another string, it's not acceptable. Okay? So, and you also discussed variables and assignments. So what for do we need variables? Why do we need variables? What is a variable? Who can tell me? Yes? Yeah, of course, it's sort of like a memory. So it's objects in the memory, and we just assign some names to them. So you have this number 3, which is integer, and it exists somewhere in the memory. And then we put this particular name A for this particular memory cell, and then we can, for instance, reuse it, print A. So we retrieve this particular value from the memory. So this A is sort of like a pointer to that memory cell. Okay, it's pointing to that. So, and this operation is called assignment, right? So on the left-hand side, we have this name. On the right-hand side, we have this literal. And the type of A, what will be the type of A if I put type here? Of course, it will be int. It will be automatically assigned the same type as the literal, integer. So you also discuss bottomless. So what does it stand for? So this is the priority of the operation. So how your expression is processed. So which operations have the highest priority? Exponentiation, right? So, and of course, there's like brackets. Brackets, they change in the priority. As soon as you put brackets, you change the priority, right? And then the orders, division, multiplication, addition, and subtraction, right? It's an abbreviation. So, and now let's move to strings. Shannon already started with some methods. So methods are sort of like functions that are specific for that particular data type or class. So again, this method is specific to this notion of classes and object-oriented paradigm that we'll discuss a bit later. So, and methods are those, again, these particular functions that you can apply on, for instance, strings. So what can you do with strings? What are the typical operations or functions on strings? You can take a string, hello world, hello world, and then capitalize. Capitalize. So what happens? It returns us a string, right? We can even assign it to some variable, b, and print it. So this method returns us this string with the first letter, which is capital. We can transform the whole string into uppercase. So there is a particular method called upper. You can also transform the whole string into lowercase by calling lower. Can you try doing that by yourself? Yeah? Oh, you mean the spelling? I think it's a great question, but I think it's pretty much American English. You see that there is no like extra function for all these Brits spelling. Yeah, a bit biased towards American English, but it's a great question. I was also, when I was typing, I was recalling like whether it's American or it's British spelling. Okay, so what else can we do? We can also ask whether this particular string only contains alphabetic characters. So there is a particular method called isAlpha. And in this case, it returns us, you see that it returns a new data type that we haven't discussed yet. So this data type takes two values, false or true. It's called Boolean. We'll cover this in a few minutes. And who can tell me why it returns false? It basically says, no, it's not alphabetic characters. If you type hello world like that. Yes? Yeah, exactly. There is a space symbol inside. So as soon as you have at least one non-alphabetic character, not part of the alphabet, so it will return false. If we remove this space character, it will all be good, right? It returns true. And we can also use methods to count particular substring in the number of times particular character or substring appears in that string. For instance, in the hello world, we have the character L that appears 3 times. We can also count the number of times a particular substring, not just a single character, but the whole substring. For instance, count LO. And let's just run this without assigning the variable. So you see that LO, this substring LO, appears 1 time. We can also search for a particular substring within a string using find method. So who can try to explain what that result corresponds to, what it tells us? What is 3? Who can guess? Yes? Yeah, exactly. So this is the index, and it leads us to the discussion of the string sequences. So it processes the string as a sequence of characters. And of course, we start counting with 0. So it's 0, 1, 2, 3. So at the position 3, we have the substring LO. We can also search for just character L. And you see that it only returns us a single number, even though there are multiple L occurrences in the hello world string. So why? Because it just returns the very first occurrence. If you want the second, you can specify the index where you start at. The starting index, you can say, okay, you just skip the first L and just start from the index of, say, like 3 or 4. Then you will match the next L. But what is important about this method, it processes the string and goes through these characters one by one. And this is our next topic, strings and indexing and slicing. So we can represent different objects as sequences, right? So we can represent text as sequence of sentences, sentence as a sequence of words, and word as a sequence of characters. In programming languages, typically you process everything as a sequence of characters. Or you can also process everything as a sequence of bytes or bits. So similarly, images can also be processed pixel by pixel. If it's 2-dimensional image, you have 2 dimensions, height and the width. And if it's 3-dimensional, you get the extra length, for instance. So, and we call such sequences and objects, such as sequences, iterable objects. And we perform so-called iteration through them. We go element by element. We can process them element by element. So, and there are particular functionalities that you can perform. So given that our sequence has these elements and they have their own positions in that sequence, you can extract a single, for instance, element or character if it's a string from that particular position, or you can retrieve a substring or a subsequence of a particular length. Or you can split the string into multiple substrings. So one is called indexing. So indexing is retrieving a particular element at a particular position. Slicing means you retrieve a particular subsequence or substring of arbitrary lengths. It can still be length of 1. It will be the special case of indexing. The indexing is a special case of slicing. So let's go through this example. In Python, so again, and as in most programming languages, again, strings are represented as sequence of characters. And our counting always starts from 0. So the very first character here, we have this string, it was dark. And the very first character, I, has a position or index of 0. And the ending character is the length of the sequence minus 1, obviously, because we start with 0. And in addition, in Python specifically, we also have the reversed ordering. So it's more comfortable for us to retrieve the very last character. So, and the reversed order, it starts from minus 1, and you go to this minus length. So now let's switch to Grok and create the variable story and assign it to the string, it was at dark. So we have it as story. It was at dark. So now, what do you think will happen if I ask story and 2? What will be returned? Yes?
Space.
So that will be a space. So it's 0, 1, 2. So we retrieve a symbol at the position or index 2. We can now also retrieve in the reversed order minus 2. So what we will return? Sorry? So it's k corresponds to minus 1 and r corresponds to minus 2. So it will be r. So this is called indexing, right? We just retrieve an element at a particular position. So again, we can retrieve the same character in 2 different ways. Suppose we want to retrieve this character k following the positive direction. So we can either retrieve it like this. This is a little bit hard coding. So in order to make it more general, so we can take the length of our story, minus 1. Or we can also retrieve it at the position minus 1. Again, the same element can be retrieved in 2 ways, in positive direction and the reverse direction. So is it clear with indexing? Any questions with indexing? Yes? At the very end? So when we just provide this 12, we kind of assume we know, like we just hard code, so it doesn't extend to the other strings. If we change the string might be longer. So it's not a good practice just to provide the exact like predefined number. So in order to make it more general, we just replace it with this expression that takes the length of the current string and just subtracts 1 just because we start counting with 0. So it's more general. It will not fail if you change your variable string. So because if I just change the story, this value of the story, so it will not work with the 12 because the string might be longer or shorter. If it's shorter, it will return you an error. Okay. So now we can also perform so-called slicing. So suppose we want to retrieve not a single element, but a number of elements subsequence or substring. So now the major difference is that we need to have starting index and ending index. Suppose we want to retrieve something that starts from position 1 and goes up to position 5, and it's very important that it's not inclusive. So you basically retrieve a substring that starts at index 1 and ends at index 4. So if we go back to this example, so index 1 is T, and we go then space, then W, then A. And S will not be included. So the ending index is not included. It's very common mistake to assume it will be included. So the substring will be T, then space, and WA. Okay? And we can omit the very first starting index. We just use the default value, which is 0. We can also omit the ending index. Who can guess what will happen? What will return? So in this case, we return the whole string. Or we can, for instance, say, OK, we start with index 3 and go up until the end of the sequence. OK? So, and now let's do some practice with negative indexing. So who can tell me what will be returned if we specify that we start at position -7? So the position -7 is here. What substring will be returned if we say that we start at position -7 and go until the very end? So this is position -7. What will be the return string? So the return string will start. So obviously, we go to the positive direction. So it's -7. It's this white space. Then -6, -5, -4, -3, -2, -1. So every time we just add +1, right? And until we reach the very end. Is it clear? OK? So now what happens if we specify -7 here? Where do we start with, and what do we end with? So now -7 is our ending index. Yeah, so we basically start from this -13 and go up until -8. It was. So is it clear? Now let's try something like this. What do you think will be returned? From -5 to -7. S, and so what is -5? So -5 is, where is it? It's here. So what do you think will be returned? Every time we add +1. Any other guesses? No other guesses? Now, surprise, nothing. So who can explain me why it's nothing? Yes?
Because your starting point is after your end point.
Of course. So we start with -5 and we add +1. There is no such substring that will match. So we basically go into the other direction. So we go to -4, -3, etc. And here our ending index is -7. Completely different direction. It will work if we swap this. Then we can extract some substring. OK? And finally, in slicing, we have the third parameter that we can provide, so which is actually the step. So if we want to force the iterator to move to this negative part, we can specify this explicitly as -1. Then we will have the string extracted. We can also, if it's negative direction, so guess what will happen if we provide this construction? Yes?
You'll reverse the string.
Exactly. So we have the whole string reversed. So we start with -1 and go opposite direction, so to -13. What happens if we provide something like, instead of 1, the step of 2, +2? Yes? Yeah, exactly. We just print every second character. So we start with I, then we skip, then we print this white space, then we skip, we print A, etc., until we reach the end of the string. We can, of course, provide this starting index, some ending index, and the step. So again, in slicing, you have starting index, ending index non-inclusive, and the step. Is it clear to everyone? Okay, that's good. So now, who knows this Sator square? Oh, someone knows, at least. So what is nice about this square is that it's sort of like an example of a palindrome, a string that reads the same forward and backward. And it not only reads the same forward and backward, you can see that Sator here on the horizontal axis corresponds to this Sator on the vertical axis. So arepo here, tenet here. So you have these matches on the horizontal and vertical axis of individual words. And of course, if you read the whole string, Sator, arepo, tenet, opera, rotas, it's the same forward and backward. So it's a very well-known thing. And now, suppose you would like to check whether it's a palindrome, whether it reads the same forward and backward. So what do we need to put in? So let's only check the whole string for now, not individual words. So let's put this str, or not, str is a bad name, it's a keyword. My str, Sator, how it reads, Sator, arepo, tenet, opera, rotas. So this is my str. So how do I check that it reads the same forward and backward? So let's first reverse the string. What do I need to type in order to reverse this string? We just discussed this. Yeah, exactly. So we just take the whole thing, and just provide -1 at the third parameter. Okay, now we see there is a string that is returned, and we can compare, right, two strings visually. Now the question is how we actually program that, how we force the computer to check that these two strings are the same. And for that, we need to introduce conditionals and the Boolean data type. So let's now move a little bit further away from programming back to philosophy and logic. So there was a lot of discussions in terms of how to represent logic. And again, previously on Friday, we mentioned that there are like ancient Greeks, they are like Boolean geeks. They played a lot with syllogisms, and they had this idea that every statement is either true or false, very binary logic, unlike in ancient India where you have fuzzy logic. So you have a statement, for instance, 2 + 2 = 4. In traditional arithmetics, this statement is true. Or other statement, 1 + 1 = 3. Again, in traditional arithmetics, this statement is evaluated as false, right? So, and we also discussed this syllogisms that have this. This is like example of the propositional logic, where you have major premise, minor premise, and the conclusion. And Aristotle was quite famous about this. So we have this, for instance, all men are mortal as the major premise. All Greeks are men as the minor one, and what we can conclude from that is that by applying some rules of logic, all Greeks are mortal too. This is our conclusion. We can, of course, represent it as sets. So we have this large set of all mortal beings, and the statement, all men are mortal, means there is a set men, which is a subset of these mortal beings. And the next statement, all Greeks are men, means that there is another subset, Greeks, that belongs to the largest set of men. And you can see that it's this green circle. The Greeks, they all are included also in the mortal beings. From that, we kind of derive the conclusion that all Greeks are mortal too. And you can go quite long, quite far away with such propositional logic. And there are different ways to use it. For instance, modus ponens. If A, then B, it's very common logic. Like if you have A, then B happens. A happened, and you conclude that B also happened. And modus tollens. You start with the same, if A, then B. And then suppose that B did not happen, and from that you conclude that A did not happen as well. Here is a particular example. Suppose we start with this general statement: if a student does not practice with coding, then the student fails the subject. So student does not practice with coding is this A, and the student fails the subject is this statement B. So, and we now have A, the student does not practice with coding, so from that we conclude that the student fails the subject. And modus tollens, it starts with the same, but then you have not B. What it means? The negation means that the student did not fail the subject, and we conclude from that that the student practiced with the coding. So those are very common rules of logic. So, and again, as I mentioned before, Lewis Carroll was very famous in this logic puzzle. He was a logician himself, and the Alice's Adventures in Wonderland is full of these logic puzzles. Like, for instance, you have a single birthday a year, but it means you have like 364 unbirthdays a year. So I would like to congratulate most of you with your unbirthdays. And he also came up with a book of logic puzzles. So here is a puzzle from Lewis Carroll: no duck waltz, no officers ever decline to waltz, and all my poultry are ducks. What can we conclude from these statements? So we can conclude that all my poultry are not officers. And it was until 1931, people believed that you can explain the whole world using the set of axioms and the rules of logic. But in 1931, Gödel came up with the incompleteness theorems that stated that it's impossible to find a complete and consistent set of axioms for all mathematics, and every time in any system there are axioms that either not provable or incomplete or contradictory. You can read this wonderful book, Gödel, Escher, Bach, that discusses this topic as well. And another examples of these contradictions are those paradoxes. For instance, the lie paradox, when you have the statements that cannot be evaluated as either true or false, like this statement is false, whether it's true or false, you never know. Or the Russell paradox. Barber who is the one who shaves all those and those only who do not shave themselves. The question is, does the barber shave himself? So, and again, you're welcome to just explore more logic puzzles, paradoxes, and let's go back to our lecture. So now, how do we represent this logic in programming languages? And what for do we use the conditionals? So, as we saw, we need some conditionals to describe whether the test is satisfied or not, whether, for instance, two numbers are equal to each other or not. We also use for that comparison operators, greater than or equal, etc. And we also, when we have multiple conditions that need to be satisfied, we need to combine them somehow. And for that, we use logic operators, such as and, or, and not. So, and for that, in Python, we have this wonderful data type, which is called Boolean data type. So, when you have true or false, it means it's a Boolean data type. And we can transform other values in other data types into Boolean. And here are the rules of this game. So, if you take an integer, unless it's 0, it's always evaluated as true. So in order to transform this into Boolean, you just type bool and provide the value. So if it's negative number, it's still true. Only if it's 0, it's evaluated as false. What do you think will happen with strings? What will happen if I put something like this? Oops. This is string false. It's string because I put this in the quotes, right? So what will be the result of transforming this string into the Boolean data type? Yes? True. Yeah, it will be true. Who knows the only condition in which we will have a string evaluated as false? Yes? Completely empty string. Yeah, of course. So this is the only scenario when you have false. It's the equivalent of 0 in the numbers. Okay? So, and then, so what do we use Boolean for? In most common scenario, you need to compare some values. So, and for that, we have comparison operators. So, there is equality operator, greater or less than, greater or equal or less than equal, and not equal. So, equality should not be confused with the assignment. So, when we have this, it means 2 assigned to 3, which doesn't make sense. It will give us an error, right? We cannot assign one literal to another literal. But we can compare them. We can ask, does 2 equal to 3? And it says false. Of course it doesn't, right? Makes sense. Now we can ask, does 3 equal to 3? And of course it's true. Now guess what happens if I take one number and put it in quotes? It means it will be string. So what it will return to me? True or false? Of course it's false. It's different object. It's different data type. We can also ask if, say, 3 is greater than 2. Of course it's greater, so the condition is satisfied, so it's true. If it's greater than 5, it's false. There is also greater or equal and less or equal, okay? We can also check whether they do not equal to each other. Of course, 3 does not equal to 5, so it's true. Now, a bit more sophisticated example. 3 is greater than 4. So probably not that one, but let me just give you another example with A as a lowercase and A uppercase. So A lowercase is greater than A uppercase. Why do you think this happens? How strings are compared? Yeah? Yeah, almost. So they have these code points, unique sort of numbers associated with this particular character. And we will discuss it a bit later, but in order to retrieve it, you can ask ORD. There's a particular function, ORD, that gives you this unique number associated with this particular character in Unicode. So, and when we perform comparison on strings, so these code points are compared. So you take the code point of A, which is 97, the lowercase a, and compare it to the code point of uppercase A, which is 65. So that's why you have this condition evaluated as true. You can also look whether A is greater than, say, ABC. So in this case, it will return us false. So because we compare first A to A, and then we have in the second string B and C. So this second string is evaluated to be greater. So what else can we do? We can also check whether a string appears as a substring in another string using in operator. So in operator can also be used in other types of sequences, not just strings. So for instance, bomb appears in bomb, 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 so you get true. So for instance, A in cat. Oops. So A appears in cat, so we get true. If we check B, does B appear in cat, it will be false. Okay? So we now have a way to compare. So let's go back to this Satur example. So what do we need to put in order to check whether this forward and backward string are equal to each other? So where is my str? So this is my str. This is this backwards direction. So how do we need to put this expression to check whether the strings are equal to each other? So we reversed it, and now we need to check whether my str equals to my str with this -1 direction. Okay, so we checked, and it's true. So it's a palindrome. But you recall that we also have some extra conditions. So where is it? It's too far away. Okay, so there are some extra conditions that need to be satisfied. We also need to check that every word, 5-character word, appears on horizontal and the vertical line. So Satur here, Arupo here, Arupo here. So we need to put together all these conditions. So, and in order to combine them, we will use logic operators. Okay, so it's here actually, okay. Where is logic? Yeah, this is the combining truth. So in order to combine several conditions, you can use logic operators such as AND, OR, and NOT. So NOT is sort of like unary minus, it's just negation. So not false will be true, not true will be false, right? It just has one operand. So AND is sort of like logic multiplication. So it's a binary operation, and it takes either true or false, right? And you only get true when both parts are evaluated as true. Otherwise, in all other cases, you have false. So it's sort of like in multiplication. As soon as you have at least 1 0, all this product will be 0, right? And OR is the opposite of this. It's sort of like logic addition. So you only get false when everything is evaluated as false. Okay? So let me give you an example. True and false, suppose like this. So of course it will be false, right? Only true and true will be evaluated as true. And if we put OR, so what will be? It will be true as well. Again, what do you need to remember is that sort of like NOT is sort of like unary minus, and AND is logic multiplication, OR is logic addition. And the priority of these operations, they also kind of reflects this unary minus, multiplication, and addition. So this NOT has the highest priority. It's followed by and then AND is followed by OR. So if you have NOT false and true, so how it will be evaluated? So we first apply NOT on false and then use the AND. So it's true and true. So true and true gives us true. Okay, so now let's go back to our example. So we checked that the full string is a palindrome. We now need to check that Satur here can be also comprised of this Satur as this first character of each word. So how do we put this expression? First, let's extract Satur as a substring. So we have my str, oops, with the underscore. So my str. So how do we extract the first word, Satur? Yes?
Extract elements 0 to 4.
0 to 4, almost. Again, non-inclusive, so that's why to 5. So this is Satur. Now we need to extract every first character of every word, the first character of every word. So how we do that? So we need to extract S, then A, then T, then O, then R. Does anyone know? Yeah?
Could we do a for loop and have a number increment by 5?
Oh, it's quite complicated. Think simpler. We have this magic third parameter. Yeah, step, but not 5. I think it's, let me just check. So it's 0, 1, 2, 3, 4, 5, 6. So it's step of 6. So we read the first character S, and then we jump by 6 to the 6th character, which is A. Then we jump to the 12th, and so on. So now we can check that it equals, we can ask, does it equal to this Satur as the first word? MyStr, oops, not 4, no, it's 5. Okay, so this is the first word. We also need to repeat it for the second word. So again, let me just print out MyStr. I always make so many typos. So how do we extract a repo? So the second, we need to check the second. So this is the first word. We need to check the second now. What do we need to change here? Sorry? So we need to extract this repo. What is our starting index? Okay, so 6. Let me just put it like this. So 6 till which one? 12. So 6 to 12, but there's, you see, there's something else, I think, extracted as well. Yeah, 5 characters, right? You can subtract 6 from 11, you get the length of the sequence. So, and now we need to extract the second part. So for this one, we have 6 to 11. And then we need to extract the second part. So what do we need? So we still have the same step, but now we need to start with the second character, right? So how we put this here? What do we need to put? Yeah, it's just 1. So it's true. Now, can you tell me what do we need to do for the tenet? Where do we start and where do we end for the tenet word? We just increment by 6, right? So 12 until, like, their length is 5, so it's 17. And then we start at the second character. And we do the same for opera and rotas. And then, at the end, we need to combine all these conditions together. So what do we get? We'll get such expression. So we need all these conditions to be evaluated true to make sure it's like full palindrome. So we check that it reads the same, the whole string, and then we check all these particular words that they also read the same in both directions. Okay, is it clear? So let's probably finalize. Do you have any questions? So we just discussed strings as iterable objects. Iterable means we can iterate through them element by element. We discussed the major operations on strings, indexing, slicing. We haven't discussed splitting. So we'll probably start on the Friday lecture with that. And we also introduced the new data type called Boolean that only takes 2 values, true or false. And we discussed this comparison operators, such as equals or greater than, less than, not equals, etc. And how we combine different conditions together using logic operators. Any questions? Okay, so I will see you on Friday then. Thank you.